Hello, my name is Kandav Shada, and here is the code that I have written for my assignment 1 for the application of machine learning course. So this is the first cell which represent all the import code that I had needed for executing the code. So there are three important library: sklearn for model training, for getting the model and calculating the accuracy scores and all that stuff. There are functions available in this library. Then TensorFlow, which contain the data set. We can use the data set directly calling the libraries function. And then cuml.svm, basically it's a CUDA based library that supports of loading the any machine learning algorithm on CUDA, on GPU, support on GPU basically. Then this is the function or pre-processed data. It's a basic simple function which normalize the data between 0 to 1 and reshape into from 2D to 1D array. Then we have apply variance threshold. This is also this apply variance and apply PCA. This both of dimension reduction method. Basically, it for apply variance, it uses deletes the feature which are not for which are having the variance below the thresholds. Okay, and PCA, it tries to combine the few features into one double. Basically, if you have a five feature and it will convert into two feature or one feature, so that it does in a such a way it does not lose its essence. Basically, it's for what it was representing into five. Okay, then we have a train and evaluate function. This is the basically core function. What it will try to do, it will take the model, it will try fit the model, basically train the model, and then it will try to input the our data, and then it will try to calculate accuracy score and all the precision, recall, and confusion metrics, and then it will return all the value in a map, basically in a dictionary. And then this is the elbow method. The elbow method is a main function. Basically it's an algorithm or a way, you can say, to find the optimal value of a k. Okay, so I have done literature survey there where they says that if you want to find a best k, you can use the elbow method. So I have used this, and I have used the here parallel processing, because to calculate the basic to calculate to train the KNN, it takes time. So I've used the parallel processing where it will try to do 10 processing simultaneously. So it will use the all power of CPU. Okay, that Google Colab provides, and then it will try to plot the graph, and we can see optimal best value for k. Then we have a run experiment on KNN. Basically, this is the main function where all the input goes, all the data loaded will goes here, and then what it will try to do, it will try to find the best k, and using the best k we will get all the data meta info, basically accuracy and all that stuff. And then we will go to the next step where we use variance threshold of feature selection method to find out what is the effect going on after applying this. And then we have apply PCA. After applying PCA, we also do the same thing. We all store all the information, and then we show that into a table format, so it makes our life easy to compare the results. And then I plot the confusion matrix for each of the steps, so we will be able to find out which classes are getting misclassified as the most and for what reason. Means we can get an idea or just about it. This is the main function. This is the main code. Basically, it load the data, flatten the 2D array into 1D, and then it will pre-process the data. This both are they're both data CFAR and MNIST, and these are the classes in it. And then it will go into those functions, and it will, as we told, it will plot the data, plot the this graph where we were able to find the best k value, and then it will create the table where we can basically try to compare the methods, which method is basically providing the best outcome. Okay, this all are the weighted average weighted values. Okay, so basically if you have two classes, cat and dog, it will do cat accuracy plus dog accuracy divided by 2. Basically two classes are there. So yeah, like that. And this is for CFA data set it has created. And then one literature survey I have done where they told if you use CNN on top of KNN, it produces a much far better results than alone KNN. So I have used this method. I use the Resner 50 model where I have updated the last layer, last full convolution layer to a simple layer where earlier it was producing the results. Right now it will only produce the embedded map or a feature map. Okay, this function will go there. It will create a, it will get the feature map in a batch wise. Basically, you have a batch of images, 10 images, and then it will go to the model, and model will get the feature map for each of the image in a batch format, and then you concatenate all the data into 1D array. Okay, and those data is being fed to the directly. If you see, this is string C for embedded and the test for C for embedded, and then we pass this in as an input to an KNN. That's it. Okay. Yeah. We need as for SVM. SVM was taking a time to treat. So I was able to find solution that if you use CUDA based SVM, then it is much faster, much faster. It is the same function as we have already discussed for KNN. Same thing, just that it is using GPU. That's it. This one thing I have introduced here is basically delay removing the garbage from GPU. GPU does not remove automatically all the garbage, so we need to write a few pieces of code so that it maintains the cleanliness in the GPU, so you can load new data easily. Okay, new data, new model. Okay, and then yeah, it's the same function like run experiment on KNN. It's a learn run experiment in CUS. We say it will try to do, says this is C is the basically value of a penalty. If model predicts wrong, how much penalty it will. If you push the limit of a C, then it will get overfitted, and if you put less value of C, then it will underfit. Okay, we need to find an optimal value of a C, so that's why I have used the same approach like we used for elbow method. Okay, after finding the best C, then we calculate all the important matrices that are needed to compare the model, and then we go for variance threshold. Same thing it will do, and the fan PCA based feature selection, and then it will show the results in a table format, and then we go for convolution neural. Oh, sorry, confusion matrix. Okay. So these are the plots that says that for C equals to value equals to 10, we are able to find the best best accuracy on MNIST data set. And for C equals to 10 again, it was able to find the best accuracy on C4 data set. Yeah. Where? That was my project. So yeah, bye. Oh yeah.